Hello, everybody. Before we dive into the technical side of our project, I wanted to start with a question. Have you ever had a song or recording where you wished you could just isolate the vocals, or maybe just hear the instruments alone? That's normally a surprisingly difficult problem, usually requiring specialized software and a decent amount of technical expertise. Our team, Team Manatee, decided to try and make that process simple, fast, and accessible. I'm Ethan Dank, and along with my teammates, Zachary Esco, Michael Morse, Jonathan Greer, and Amy Brightbill, we created the Manatee Audio Processor, a web-based platform that gives users access to two major features. The first, vocal separation, isolating voices from a noisy or musical background, and the second, music stem separation, splitting full songs into distinct instrumental tracks such as drums, bass, vocals, and everything else. We built this using Python, Flask, and HTML, and connected it to a powerful AI model to help with the separation of the audio. Everything runs right through a simple, easy-to-use web interface. You upload your file, choose a separation option, and download your results with just a few clicks and a little bit of waiting time. No complex setup required. While we each had our areas of focus, Jonathan focusing on vocal separation, Michael on music separation integration, Zachary on documentation and aligning the core features, and Amy and myself working on UI design and backend Flask, our work was highly collaborative. Everyone contributed to the initial research, design decisions, and troubleshooting across the stack. While we each had our focus areas, progress was made through a shared effort and efficient communication. Of course, the project was not without a few obstacles. One major issue we ran into was keeping the separated files clearly organized. At first, the music stems were being saved into a shared directory with no folder distinction, which made playback and user clarity a bit of a mess. We resolved this by updating our file routing logic and folder structure to group the stems by original file name. Another challenge we ran into was merging our two separation tools into a single cohesive platform. We needed to make sure that each model handled only the right kind of input and that required clear backend separation and route handling in Flask, which we resolved through carefully scoped file directories and logic checks. As you can see, the platform automatically handles uploading, processing, and presenting the separated results for playback or download, all with just a few clicks. That's a quick overview of the Manatee audio processor. From here, my teammates will walk you through a bit of a deeper dive into the details of how the model works, how the interface was designed, and the final stages of integration.
Hello everyone, this is Jonathan Greer, and I'm going to show the part of the project that I created the source code for, and that is for the vocal separation. So first I'm going to show it working and everything, and then I'll show the code and how it works. So select one of these sample.wav files, and hit separate vocals. So first we'll play the original audio so you know what the source file sounds like.
He hoped there would be stew for dinner, turnips and carrots and bruised potato.
Okay, and now it's separated into two different tracks with each of the voices separated into each file.
I shall be punished for it now, I suppose, by being drowned in my own tears.
And then the other voice.
He hoped there would be stew for dinner, turnips and carrots and bruised potato.
Okay, now just showing one more so you can see that it works for multiple files.
Yet that task was not so
Fresh
easy as you
Nellie
may
is waiting
suppose.
on you. Number 10, Fresh Nellie is waiting on
And then the second one.
Yet that task was not so easy as you may suppose.
you.
So there you go, you have them correctly separating. And then we'll just talk a little bit about the code and how everything works. So first, we check for file eligibility just to make sure that it's one of the correct file formats. We had to resample the file into a sample rate of 1600, so that way that the AI model can properly separate the audio files. Right here, we split the audio into 3-second segments. Again, because that is what the audio or the AI model requires, is 3-second segments so that it can look at the file and everything. This normalizing audio function is just making sure that it's not too loud. And then the perform sep is just what actually separates the files and makes them into two different ones. All right, thank you. That was all.
Hello, this is Michael with Team Manatee, here to talk about the implementation our group has for separating music sources in our project. The model we're using is trained using the Muse DB18 dataset. We're using the uncompressed version of this. It's a dataset of 150 songs from a variety of genres, along with the isolated instrumentation for each song in the dataset. Everything's uncompressed, so lossless WAV files encoded at 44.1 kilohertz. There's a training set of 100 songs and a test set of 50 songs, and it's licensed under the Creative Commons, so it's an open resource for anybody interested in this topic. And using that dataset, we have our model. It's a pre-trained model known as DMUX. It was developed by Alexandre Defaussé when he was at Facebook AI Research, and the latest version of it that we're using is HT DMUX, which gives us a much better signal-to-distortion ratio. And it's a hybrid approach using transformers that encodes a given audio file into a spectral domain and a temporal domain, and actually combines those representations, if they align, to assist in giving the model a better prediction rate. And if you know where to look in the documentation for this pre-trained model, you can actually perform music source separation, thankfully, in one line of code. So I can pass the absolute file path for a song into the model, and the model will produce an output for the vocals separated, the drums separated, the bass separated, and everything else into respective audio files. It can be specified as something other than MP3, but for our project we have chosen MP3 for convenience and ubiquity, given that a lot of users of this project would likely use an MP3 file and pass that to the model. And here are my references, and now I'll turn things over to Amy.
Hi everyone, today I'll be walking you through the front-end implementation of our Manatee audio processor application. Our goal was to create an intuitive, user-friendly interface that makes audio separation accessible to everyone. Let me start off with our base HTML file, which serves as a foundation for our entire application. We've created a templating system using Jinja 2 that allows us to maintain consistency across all pages. The base template includes a responsive navigation bar, consistent styling with a teal color scheme, flash message handling for user feedback, and content blocks that child templates can override. The home page extends our base template and organizes content into cards. Let's look at how we have structured this in the HTML. Here we are using Flexblocks for responsive layout, and each feature has its own card with descriptive icons. Buttons are styled consistently with the clear call to action text, which allows users with a clear overview of the application's capabilities. For file uploads, we've created a simple form that posts to our backend. The HTML includes file input with appropriate constraints with using the accept attributes, clear instructions about supported formats, form validation to ensure required fields, and styled form elements for better user experience. Our audio player page dynamically generates content based on available files. The key HTML features include conditional logic with Jinja to handle different file formats, audio elements with proper source attributes, delete forms for each file with post method for security, and custom CSS to ensure consistent audio player styling. The music.html page provides the interface for a music separation feature. It has a drop-down selection for choosing audio files, form validation to ensure proper selection, processing time expectations clearly communicated, and empty state handling with redirects to upload. After processing, separated music.html displays the results, an original audio reference at the top, separated tracks organized by instrument type, nested loop structure for handling multiple output files, and consistent audio player styling throughout. Our vocal.html page mirrors the music separation interface. It has a similar form structure for consistency, clear instructions for users, error state handling when no files are available, and consistent styling with the rest of the application. The separated vocals.html page shows vocal separation results. It has a status message to communicate processing outcomes, original audio for comparison, separated vocal tracks with appropriate labeling, and navigation buttons to return to previous steps. Throughout our front-end implementation, we've maintained consistent design language across all pages, intuitive user flows between features, proper error handling and empty states, and responsive design for all screen sizes. Now we will be looking at the full implementation with Zach.
Everybody, my name is Zachary Esco, and I am on Team Manatee, and I'll be showing you our audio processor. First, here you can see our home page, and it's got all of our functionalities nicely separated. Here in our first functionality, you could see the audio library that comes default, and I've added a few things here. If you want to add your own file, you just go right to upload, choose file, pick whatever .mp3, .wav file you want, and it'll pop right into the library. And using that library, you can go to your music separation tab. You can go down, click any of the files from the library. I chose Heartbreaker by Led Zeppelin. It's a good one. You just press separate music, and this takes a couple minutes, so I've got it all split up right here. Here you have the original audio, and then you've got different parts of the audio all split up in their own way. This one will be just the drums, just the bass, the rest of the sounds, the vocals, and all you need to do is go here, click download, and boom, pops right up in the downloads folder. Our last functionality that we added is more for vocal files like a podcast, radio talk show. And the goal is to split the file up into the different voices and the different people talking. So here I'll pick a podcast, press separate vocals. I already had this one done too. And you've got your original audio, and then you've got your first guy speaking. And here you should have the second guy starting to answer his question.
And I've been working on this.
And yeah, the goal here is just to take the audio, split it into the two voices, and give it back to you. So you just press download, pops right into the folder, and there you go. That is our audio processor project. Thank you.